Good afternoon. Good
Hello
afternoon.
there.
We can. Okay, we have some action. That's good. Okay. All right. It's 12:30. We'll get started here. Do a share. I hope you all had a chance to. Hope you all had a chance to do a little watching of some videos. And the main thing that I sort of wanted to maybe hit on here is the fact that most of the mechanisms that we cover here go with one of these three patterns. I had introduced this to you before spring break, and it's these three mechanisms: the acidic mechanism, the neutral mechanism, and the basic mechanism. And it's pretty easy to distinguish between the three because one has H plus on the arrow, that'll be the acidic. The neutral has something neutral on the arrow, something that's not charged. And then the basic one is generally going to have something negative on the arrow, so X minus, some sort of negatively charged species. And once you know that, you can see what the product is going to be. But if you look at the general pattern for each, it's going to be identical. You'll see that the Y, which is the group on the C double bond O, gets replaced with the X group, and then the H that's with the X joins with the Y, or whatever this happens to be, if Y minus here in the case of the negatively charged one. But the whole point is that you can see that the Y group gets replaced with the X, which makes figuring out the product generally fairly easy, and generally not requiring any kind of having to do the mechanism in order to get the answer. Now, on the test, one thing I can guarantee you is that in question one, I haven't gone through this yet, but in question one, 80% of the questions on question one, 8 out of 10 will follow one of these three patterns: acidic, neutral, or basic. And the other two could possibly be ones that I consider to be oddball. They don't follow either of these patterns. And we've already gone through some of these, excuse me, some of these, and tried to figure out, whether they're acidic, neutral, or basic, and then followed that same mechanism in order to determine what's going on. So I had asked you during last week to go over some of these videos here, the ones that were marked with day 2 and day 3. And you would have hopefully gone through these and looked at them. Now, I know there were a number of them, but most of them are fairly short. I mean, it's certainly less than 10 minutes on all of them, I believe. Some of them less than 5 minutes, hopefully. But they all go through the mechanisms and everything else that went along with those specific reactions. Now, let me see what's going on here. Somebody's put something in chat, and I'm just trying to figure out what they've put. Let's have a look. Lactone ring was not short. No, you're right about that, Peter. But that one is covering, and that one's covering a whole other question that we haven't been through yet. So I guess, yeah, which one are we talking about there? Lactone formation or dual rings. These two here, Peter. Yes, you're quite correct. Those two are not short. Those are the basis, though, of one of the mechanism questions, which we have not gone over yet. And I'm going to spend some quality time on those too, Peter. Now, the other reactions are all pretty much following one of these three patterns as I went through here. So what I'm going to do is, I guess, go through some of these. Well, I suppose what I could do is all right, tell you what I'll do. Hang on, let me close the door here. All right. I did get an email from somebody last week requesting that I tell you what kinds of questions are going to be possible for the test on question 1. So I'm going to honor that request now, and I will go through. This is in the blue book, or problems test 3. I'm going to go through each of the reactions and tell you what kind of reaction it is and what pattern it follows. And I do that by starting at the reaction summaries, which start on page 9 of test 3 here. So I'm going to go through and tell you what's what here. Yeah. Okay. So I don't know. I'm trying to figure out the best way of doing this. I suppose if I just do it here, then people can go back and take a look at it later, and they can write it down on their own sheet later on, because I'm going to obviously post this recording. But if you happen to have the blue book in front of you, I recommend you open it at page 9. Can I get an idea? I'll do a poll here. I'm going to do a poll. And I'm going to find out who has a copy of it.
Dr. Musgrave?
Yes?
Wasn't there a video? I thought I saw a video that you went through all the things, because I don't have a copy of the blue book, but I saw all of them. Or a video or a sheet that's already uploaded.
I don't know. Does anybody know what Julie's talking about? Because if there is already such a sheet, then I don't need to go through this.
I'm just, I mean, maybe I'm wrong. I'm just thinking that I saw something. I can't remember if it was a video.
It seems like you're not crazy, Julie, because Jasmine agrees with you. So either you're both crazy, which I find that hard to believe, or it exists.
Oh, no, what I was trying to say is I have this sheet because you uploaded part of the blue book, is what I was trying to say. I printed it out already.
Oh, okay. Right.
Yeah.
So you
I haven't seen that video, though.
Oh, okay. All right.
It may not be a video. It may be a sheet. I just saw something that had what you're talking about.
I think what you might be
about the sheet.
I tell you what you might be talking about, Julie, is that in the back of test 3, there's a whole bunch of problems. And what I had uploaded was something a student had done where they actually classified what each of the reactions was.
Yeah.
I think that's what you might be talking about. What I'm going to go through here, I don't think I have as a sheet.
Okay.
All right. So I'm going to, let me just continue with what I'm doing here. Do you have a copy of the blue book in front of you? Actually, I should say a paper copy. Let's be more specific. Or something you can annotate electronically. Because some of you are using tablets and stuff and writing notes and stuff. That's all beyond me as far as technology goes, but I know that people are doing that kind of stuff. Or something you can annotate electronically. All right. And I just want to get an idea here so that I know exactly what I'm going to do here. Yes, no, save, okay. All right, let's go. Polling, here we go. All right, so could you please fill out this poll, please? All right, everybody's voted. I'll end the poll. Okay, so it seems like 15 of you have something in front of you. That's really good. I want you to annotate that. And the other 4, you're going to have to go back through this video after I post it and then print out a copy of the blue book, which you should already have, by the way, and print that out and then go through and do exactly what I'm doing here. Okay, so most of you, 15 of 19 of you have that. Anybody who's watching this later will obviously be able to do this as well. Okay, so we're starting at page 9. A oxidation, I would call that O. Let me tell you the legend here. O is going to be other, A is going to be acid, B is going to be base, and N is going to be neutral. I'll say that again. O for other, A for acid, B for base, N for neutral. So I'm going to go through for each of those. So A here, oxidation, that's going to be O. Grignard reaction, technically B/O. I'll say B/O for that one. Anything that's got acid or base written next to it is going to be considered acid or base. So we don't have to do any of those. Is everybody clear on this so far? Does anybody have any questions? All right. Thionyl chloride, O. Synthesis of acid anhydrides. I'm really only considering this reaction with acid chloride. I would call that B for basic. The carboxylate ion formation you can classify as O if you want. Methyl esters from diazomethane, O. Acid chloride plus alcohol, N. Esterification, A. Lactone formation, A. Anybody got any questions so far? Am I going too fast? All right.
A bit fast.
A bit fast, Julie. Okay. Are you up with me, Julie?
No, but I'll find it.
All right. Are you on? You have it in front of you? You said, right?
Yeah, but you flipped it fast on the second page when I was looking for it on the second page. It's okay.
All right. You can go back to syntheses of esters. We're talking about page 11 here, or actually no, it's page 8, I suppose, on the thing.
Yeah, you got oddball and neutral.
Oddball, neutral, acid, and acid. Okay. Now we've got the lactone formation. That's the ring closure. I'll get to that in a bit. Synthesis of amides. This is on page 9. What should be page 9 in your document? Is amidation, that's going to be A, because it's got the H plus in it. The reaction of acid chlorides with amines, that's an N for neutral. Lactam formation, that would be A for acid. Everybody up with me? Okay. Syntheses of nitriles, nucleophilic substitution, that would be O for other. Dehydration, O for other. Reactions of acid chlorides, A, hydrolysis, that would be N for neutral. Reaction with amines, that would be N for neutral. Reduction, that would be B for basic. Reaction with alcohol, that would be N for neutral. Organocopper lithium reagents, that would be B for basic. Hydrolysis, acid and base, it's already marked. Esterification, acid and base, it's already marked. Amidation, that's acid. Esters, reactions of esters, acid and base, it's already marked. Transesterification, acid and base, they're already marked. Amidation of ester, that's acid. Reaction with Grignard reagent, that's a cross between basic and other, so B/O. Ester reduction, I'd call that basic/other as well, B/O. Lactone hydrolysis. Is everybody up with me? Okay. Lactone hydrolysis, acid and base, it's already marked. Lactone esterification, acid and base, it's already marked. Lactone amidation, that's acid. Lactone reaction with Grignard reagents, that's B/O. And lactone reduction, that's B/O as well. Reaction with amides, acid and base, it's already marked. Lactam hydrolysis, acid and base, they're already marked. Hoffman degradation is other, O. Reactions of nitriles, acid and base, is already marked. Reduction with Raney nickel, that is other. That's it. So that's all of them. So most of them are either acid, base, or neutral, and there are some there that I marked as other. So what I can tell you about test 3 is that the questions in test 1, 8 of them, at least 8 of them, will be A, B, or N. So acid, base, or neutral, and a maximum of 2 would be in the other category. That's it. That's what you're going to get. That's what I'm going to tell you. So as far as studying for the test, my recommendation is pretty similar to what it was for test 2, which some people followed and some people didn't. But the reactions, they start on page 22 of this document, or what it's called, page 22. It's actually page 29 of the PDF. Excuse me. But it's marked as page 22 here. I put in some other pages, I guess, as I went along. Oh, no, I see. Well, no, it looks like the page numbering got screwed up. That's what happened. All right. Anyways, there's this, after the reaction summary, there's a bunch of problems. Let's see, how many are there? 57. And each of these has answers that are present here in the document afterwards, but the mechanisms for all of these problems are in this document, test 3 mechanisms. And there's one per page up to 57. So just look at these and figure out which one you have, and then you'll be able to base your answers, or look at your mechanisms and then use those mechanisms as a guide to see if you're doing them correctly. Now, how many people are actually going to do this? Probably not very many, but I can guarantee you this. Some people will get away with it and not actually need to do it, but there's a whole bunch of people who need to do it who won't do it, and those are the people who are going to fail. And it never, well, this is the way it always goes. I mean, I've been doing this for a lot of years now, and that's what I've noticed about this test. There's no reason really that people should fail it, except that they don't do the work, or they expect that they should be able to pass it without doing any work. And that would be unpleasant. There is also the document here. This is the one I think Julie was talking about. And this is the reactions sheet for the assorted problems. So for the problems I was just talking about, somebody needs to mute themselves. I'm not sure who it is. Elise, I think it's you. Thank you. And these are the very problems I'm talking about. And you'll notice that what's happened is the student has gone through and then classified each of those reactions. So if you are concerned or you want to know which reaction these refer to, then you can just look at this sheet if it's something that's going to be bothersome to you. All right, does anybody have any questions?
Yes, Dr. Musgrave.
Yes, Courtney.
For the 57 problems that you just showed us, are those all of what will be on question 1 pretty much?
Yeah. Except
Okay.
I've been a little bit more specific than that. I've told you that 8 of the problems on question 1 will be acidic, basic, or neutral.
Right.
And you know which ones are which now because I've gone through and told you.
But for practice, like everything we would need to practice would be in those
Yes.
57? Okay,
Yes.
perfect.
I agree with that statement. Yes, I do. I think you'd be fine.
Thank you.
But the other thing, of course, is you'll have the old tests to go off as well. And you'll see that they pretty much follow what I had said about 8 of them being acidic, basic, or neutral, and then 2 of them, or at least 8 of them being acidic, basic, or neutral, and then 1 or 2 of them being other. But the whole point of it is I want people really to focus on the pattern here, and you can see that most of the time that's the pattern that they follow is going to be this Y being replaced with some sort of X group that's on the arrow here. And it makes it pretty easy then to determine what the product is going to be. All right, so that's going to be the main focus of what I'm going to go through today. All right, so I'll close that down, I guess. I wonder where, maybe I, all right. I must have closed down another tab here. Okay. I didn't open it. That was a problem. Okay. So when I last saw you, that was just before spring break, we had gone through, I think, pretty much up to here. The syntheses of carboxylic acids or acid chlorides. I think I might have gone through that. Might have gone through that as well. Okay. Does anybody remember where I stopped? I can't remember.
You stopped on esters.
Esters.
On synthesis of esters, you went through it, and then we ended there.
Okay, fair enough.
But you did not get to the esterification. You just did that first page, A and B.
Okay, yeah, all right, that sounds right. Yeah, so here. All right. Now, if we look at this reaction, I'm not going to go through all these reactions because what I'm planning on doing here is just sort of hitting the highlights and trying to show you how to get the products of these reactions without having to do the mechanism. And then I'll also focus on the mechanisms for the more common ones, whether acidic, basic, or neutral. So you can just follow the same patterns in order to get those. So, it seems like there's a lot of reactions. Yeah, I mean, there's like 40 or something, or 45 of them, something like that. But most of them follow that pattern, either acidic, basic, or neutral. So really, it's only 3 mechanisms that you have to be aware of here. So let's, first of all, we'll focus on the esterification. And I'm going to do, let's get rid of that. Okay. And this is a reaction that we did in lab already to make banana oil. Can you say banana? I can say banana. You guys don't say banana. You say something else. Well, actually, why don't I do I'll do that banana oil reaction. This is what I'll do. Let's do that. Okay. Let's focus on getting the product here first. Now, according to my oh, I don't want that either. That is something I want to get rid of. Come on. Come on. Trying to get rid of this. It won't let me move it. Nah. Just move this down here. We'll get rid of that. Okay. Let's see if I can find this other document. Here it is. So according to what I've got over here, this one is an acidic process. And the reason I know that is because of the H plus down here. So what we're looking at is the X replacing the Y and the H that was attached to the X being attached to the Y. So let's look and see if we can identify those features. So this whole thing here is going to be X. This whole thing minus the hydrogen is going to be Y, so it's YH. Now the product, according to my pattern here, is going to be the Y group plus the OH being attached to the H, which is of course water. So that's how you get the product. Does anybody have any questions? Does anybody have any questions at all about this? You're going to get tired of this because I'm going to continue showing you this product, you know, this kind of thing. Okay. So let's go from what we're doing here. This will be, whoops. Let's do the mechanism here. Now the mechanism is going to be based on, again, this same document that I've got over here. It's going to always follow this same pattern. So the H plus attacks the C double bond O. Then the O from the nucleophile comes in, attacks the C plus. Oh gosh, what's going on there? Let's try that again. Oh, it's crazy. Oh, what is happening here? Something is amiss with my pen. Oh my gosh. Oh, my pen is going nuts.
Does it need to be charged up?
No.
Mine does. Goes, I guess, hooey.
No, the pen doesn't have a charge on it. Oh. It seems to have gotten stuck somehow. It's something is amiss. It shouldn't be doing what it's doing. Oh. No, golly. Oh, golly. All right. I'm going to have to close this down and restart it. Close down this page. I'll restart a new page here and see if that helps me. Helps it go less crazy. Okay. I think we're okay now. Wow. And what I might do is might put this next to it anyway. Okay. There we go. Now it's behaving itself. That was very unpleasant. All right, so this is what we had decided was the product. Does anybody have any questions about getting this product just by not doing the mechanism? Y, X. There's your Y group there. And the X group is with the OH here. Okay. All right, so going through the mechanism. And we're having the nucleophile here attack that C+. This is where I went crazy last time. And when we do that, we get a positive charge on the oxygen. Now, one of the immutable things that we talk about with this mechanism is that we do a hydrogen transfer, a proton transfer, and it always goes on the leaving group. And the leaving group is always whatever was attached to the C double bond O. So I'm just going to go for that. Now, technically, it wouldn't matter which OH because they're both the same, I suppose, but sometimes this isn't OH. And it's always going to be that group that gets the proton in the proton transfer step. Does anybody have any questions? Okay. And one of the things we talked about back in test 2 was that after the proton transfer step, I'm going to not be lazy about this. Let me redraw that a little bit, make it a little bit more palatable. So we can see that bond being lost there. But after something gets protonated, it tends to leave. And when it leaves, we end up getting, this is our product. Okay. And that's going to be H plus and H2O as well. And you'll notice it does follow that same pattern that we have here for the acidic. So regardless of what the X or Y group is, this is the way that the mechanism will always go. So that's why I'm saying a lot of these just follow the same mechanisms. Does anybody have any questions about this mechanism? That's why I'm saying you should obviously be practicing these. Okay. So I'll just, okay. So that's esterification. Now for the lactone formation, I think I might actually go through question 3 on the test here. All right, so let's open up one of those questions. All tests. Okay, let's have a look. Let's look at spring 2016. Okay, so just looking at this test here, let's go through and classify each of these as A, B, N, or O, just so you can get the idea of what I'm talking about. I want to check for updates on that. Okay. All right. So for this one, this would be N, neutral. This would be B/O, based on what we had gone through. This one would be basic. And you might be saying, well, NaOH, that's, well, NaOH, you might say, well, that doesn't look negative to me. Well, it is Na plus OH minus. So NaOH is basic. Now this one's acidic. This one's acidic. This one is other. That's a diazomethane reaction. This one's acidic. And this one is acidic. This one is neutral. And this one is other. I suppose that's the other thing I can tell you is that there's always going to be one question of the 10, and I should have said this, that would be this kind of problem where NaOH is reacting with a carboxylic acid, or some sort of base is reacting with a carboxylic acid. I think what I might do is just sort of show you how easy it can be to get the products of these using the patterns that I've set forth in this document over here. Right, so I've already said that this one here, and it might be helpful to take the COCl and go ahead and write it out as an acid chloride. All right, so why don't you all try this? See if you can come up with the product of this based on the neutral mechanism, but don't do the neutral mechanism. Just see if you can figure out what the X and Y part are. I'm telling you it's neutral. Now you just have to figure out what the X and Y are, and then what the product would be. Is 2 moles, it says there. Well, don't worry so much about the 2 moles, but just go through and see if you can figure out the product. I need to get back to where I was here. There we go. Let me close that a little bit. All right. So by yourself, see if you can figure this out. Don't tell me, no, you can't do that to me. No, I'm not doing it. That's annoying. Trying to make me sign in. I'm not doing it. All right. Damn it. All right. So here's what you should have done. So this here is the Y group, and this business with the hydrogen attached to it is the X. So the product should have been this. Okay. Plus, I guess HCl. Effectively, if we're just talking about 1 mole here. We haven't gone through this reaction, so I'm not going to worry about that, but that's the main product right there. I mean, that's what I'm trying to get you to do. Now, if it's 2 moles, I think this is a reaction that you might have gone through in the videos, but I can't remember if you did or not. Then what happens is that the HCl joins with another mole of the amine, and we end up getting this. So the 2 of these would be the actual answers. But my point here about doing this was just to show how you could easily get at least a product, one of the products, by showing the reaction of the X group and the Y group and how they're replacing each other, substituting. Does anybody have any questions? I'll probably end up going through that reaction again. I haven't done that yet. I was going to do a poll for that, but unfortunately my polling tool isn't working here properly. I'm going to skip over this one because it's kind of a base/other. But let's look at this one here. And we'll see how that follows the pattern. So I'm going to put the NaOH as OH minus. So the groups that we've got here, effectively this whole thing really, is the X group. No, the Y group, I should say. And then the X here is X minus, the OH minus, and we're following here. Again, this thing's going to give me trouble. All right. And we're following here this basic mechanism here. So the Y group ends up being replaced with the OH minus. So this is a cyclic thing. So you'll see that what happens is that the O group gets replaced with that, and then let's see, 1, 2, 3. We end up with that, and then that can be protonated with the H plus, and then that gives us our product. But again, it's following this same pattern. The O minus here happens to be the Y minus. So even the cyclic ones follow that same kind of pattern. I think you'll probably understand that better once you do a bit more of these. I guess what I'm just trying to do is show you that it is possible to get the products just by doing the mechanisms. I mean, sorry, just by following that pattern, not necessarily doing the mechanisms. Let's do this one here. This is one very similar to the one we just did. So this is following the acidic mechanism because it's got the H plus on it. Do that. So there's your Y group. There's your X group here. And then the product is going to be the X replacing the Y. So this is what I'm trying to show you. Just trying to convince you of the fact that they're all following this same kind of pattern, or a lot of them are. Does anybody have any questions? Is that other reaction? I'll do this one as well. So sometimes it helps to draw these out as actual functional groups. So again, here's your Y group, here's your X group, and then the product is going to be that plus water. Does anybody have any questions? Yeah, I wish I could do these bloody polls, but unfortunately it's telling me that I'm not logged in, which is weird. All right. I'll see if I can get that to go in. No, I don't think I'm. I don't know. Whatever. Okay. Very annoying. Yeah. All right. Let's have a look. Okay.
Now, is this one acidic because it has the H plus?
That's right. So give this one a go yourselves. Now that you've sort of seen a few examples, see if you can figure out what the product of this, even though we haven't gone through this reaction, see if you can, you might have gone through it, you went through the videos, but see if you can figure out what the product is just based on the pattern that I'm talking about. So I'll give you another minute or so to figure that out. I'm not asking you to do the mechanism, just show the product, that's all, or products. Now I'm just going to draw this out, not do the actual thing yet. Okay. So this entire thing here is going to be the Y group. And this business here is going to be the X group.
Can I ask a question?
Yeah.
How do you know that the Y group is the whole entire thing on the left and not the whole entire thing on the right?
Because it's got the oxygen in it, and we're only talking here about carboxylic acid and carboxylic acid derivatives, Julie, which were the functional groups that contained these other heteroatoms, O's, N's, and Cl's.
Okay.
So it makes it pretty easy to decide which side you're actually talking about. Do you think, is that okay, Julie? Okay. So that would be the product. You can see that that's going to be the X group there, without the hydrogen on it. And then this business here is going to be the Y group without the hydrogen on it. So those would be the products. Does anybody have any questions? Again, I wish I could do a poll on this. Is there any, well, let's see, I might have to, I'll see if I can sign in again. I don't know. See what this second poll is. All right. Well, let's do it. I guess I already had this one. Okay, I'll give you another 5 seconds. 4, 3, 2, 1. Okay. So as you can see, and but nobody's asking any questions. So I don't know. It's a bunch of you halfway understand it, but I don't know. I'm not really. But nobody's asking any questions. So spit it out. If you don't understand, what questions do you have about it? What's the issue?
I guess what I did wrong is I didn't know what to do with the other part. I guess I just forgot from the videos. That's all. That's why I did halfway. The Y part.
The Y part. Well, the Y part is what's on the Y part is the part that's connected to the C double bond O. It'll always will be, Jasmine. So that gets replaced with whatever's on the arrow minus the hydrogen. Sorry?
Yeah, the X part. It's just at the end. What I had was I just had like I didn't attach the H to the O, so it was floating. I wasn't thinking.
Okay, fair enough. Yeah, there would be two products, Jacinth, because one of the directives, and this was a directive that I had back in test 2, was that you need to include any products that have carbons in them. Any products that have carbons in them are going to need to be shown. So if there's a product that had water, you wouldn't technically have to show the water. But if you got a product that has a carbon like this one, you would definitely have to show that. If you just want the credit for the actual products. So yeah, you'd have to show both. All right. Any other questions? Anything else that here that can help you? All right. Let's try this one. I will write it out a little bit more just so you can see it a little bit more clearly. All right. See if you can get the products of this one. Now this is a neutral mechanism. All right, I'll give you say 30 seconds to come up with a product. Okay, here's what you should have had. So there's your Y group, and here is your X group. So the X replaces the Y, and the Y group joins with the hydrogen here. Okay, so let's do the pole again. All right, what about this one? Okay, a whole lot better this time.
Ask a question?
You certainly can.
Okay, so I'm looking back here, and when you did the esterification, you
Yeah.
said the Y replaces the X.
Yeah.
And that was in an acid reaction.
Right.
Neutral, you're saying the X replaces the Y.
Well, it depends on what you're calling Y and X here, but I mean, looking at the, did I get them? Did I change them around, or whatever? The Y is always what's attached to the C double bond. I might have misspoken Julie?
Okay, so the esterification was, it's still
It's
the
the same.
extra places that
It's
Y.
just, yeah, it's still the same.
Okay.
I might have misspoken and said the other way around.
Okay,
All right.
not a problem.
Okay. So for this one, people understand this a bit better. So for the 3 people who halfway understand, does anybody want to be brave enough to ask me a question?
So it's not really a question. I know what I did wrong. I just instead of replacing the chloride on there,
You did the other side?
I don't know how to explain it. I drew it out. Instead of putting the oxygen with the substituent group on there, I put OH instead. So I see what I did.
Oh, okay.
Yeah.
All right. So, when you got XH, Anna, it's always, you always look at the group, sort of isolate the hydrogen that you can usually see, and then just circle whatever's left, and that becomes the group you're going to use. I think that would be helpful. Anybody else from the 3 people who wants to share anything about this?
I just flipped, where you have the oxygen, not the C double bond O, but the oxygen by itself.
This one, yeah.
I just flipped those.
Right.
So the O would be on the left, is what I did.
Right.
And then the rest of it was on the other side of the C double bond O.
So you replaced the other group, not the CL, is that what you're saying?
Yeah, that's what I think I did.
So the group that you're always replacing, the Y group, always has a heteroatom in it, something that's not carbon.
Okay.
Okay, so just focus on that side of it, whatever happens to not have carbon on it, and that will tell you the Y group.
A heteroatom. Okay.
Yeah. Something other than carbon.
Does the X replace the Y on all 3, acid, base, and neutral?
Yeah, you can see them here. But it's kind of like in the basic, the X minus replaces the Y and the Y becomes Y minus. It's a little different, but it's still the same kind of concept.
What about the oddballs?
The oddballs, well, no, but they don't follow the same pattern. That's why that's what makes them oddballs, Julie.
Okay.
Because they don't follow those patterns. Now this last one, and as I said, there's all of the tests follow this same kind of thing. They have this reaction in there. But if you've got a carboxylic acid reacting with a base like NaOH, what's going to happen is that well, I'll show you the mechanism for it. It's very simple. I told you it's on every single test. Carboxylic acids are simply acidic. Sorry, they react with bases to form the anion, which is this. That's it. That's all that happens.
Now, is this basic or is this oddball?
Well, I see it as being oddball because it's not reacting specifically with the C double bond O, but it is a reaction that is going to be on every single test, Julie, including yours, the one that you'll take. Something like this, where something basic is attacking the carboxylic acid.
I'm guessing if I forgot the negative, that would be wrong. Yes,
absolutely, it would.
I was rushing.
Yeah, well, one thing about these reactions, Peter, is there's always conservation of charge. So if you have sodium hydroxide, then that becomes Na plus OH minus. The OH minus that does the attacking, the Na plus is just going to be a spectator. If you had O minus Na plus, that wouldn't be wrong, Peter, if you did that. But you certainly need the negative on the O if you're doing it the way I'm doing it here. All right. Let's focus on question 2 here, which is the lactone ring formation problem. All right, so let's look at the reaction that this is based on first, and then we'll go through this. I'm not going to get through all this today, by the way, but I will be. I'll be starting it today. Oh, I don't want to do that. I want that for later. Okay. Where are we? Okay. All right. Yeah, so we're looking at lactone formation, this one here, D. So I'm going to go through an example of that, and then I'll show you how that applies to problem 2. So this is going to follow the acidic mechanism, but let's go through and show the mechanism for it. So lactone is a cyclic ester. So this was esterification, which involved a separate alcohol reacting with the carboxylic acid. Here, the difference is that the OH is actually part of the same chain. So what we end up with here is this situation. Let's see, 1, 2, 3, 4. We'll do this one as an example. The only thing on the arrow is H+. Now the product here, it's a little bit more convoluted than what we've been doing because we're involving a cyclization here. But the X group is effectively this one, and the Y group is effectively this, the OH being the leaving group. The product is going to look like this. 1, 2, 3, 4, 5. Plus H2O as a product. So let's look at the mechanism for it, and that will help you to see the pattern here. This is a mechanism you definitely have to know anyway. Let me make it so it's a little bit more consistent with what I got here. There we go, it's better. So the first step is the attack on the H+. Then the nucleophile, which happens to be the OH that is on the end of the chain here, that's going to be doing the attacking. And that's the cyclization step. Now what can help here is if we number these carbons and the oxygen here. This gives us an idea of how many things we're expecting to see in the ring. So what we'd have here is and that's really the hardest step right there, is understanding exactly what's going on with that cyclization. I'm going to stop there for a second and see if anybody has any questions about what I've done there.
I do.
Yes, Julie?
Why is the O from the right-hand side attacking it and not the O from the left-hand side?
Well, the O from the left-hand side is attached to the C with the plus already. It's the leaving group. It can't be doing the attacking.
Okay.
So it has to be, well, yeah, we already know what the leaving group is. The leaving group was what was attached to the C double bond O that has the heteroatom in it, Julie. So that's COH. So whatever has to be doing the attacking is whatever's on the end of the other chain here.
Could you say that again? What makes that the leaving group?
The fact it's got the heteroatom in it, it's got the O in it.
Okay.
Remember that the the leaving group is always going to have N, O, or Cl, right? Attached to
the other side had an O2.
Yeah, but not attached to the C double bond O, right?
Okay.
What's attached to the C double bond O on the other side is C directly. I mean, what's directly attached? You've got a C, right?
Yeah.
So that can't be the leaving group.
Okay.
So whatever else is attached on the other side, that's always going to be the leaving group. Now, the deeper answer to that also, Julie, is that you've got to be asking yourself, well, what carries a negative charge better, the O or the C? So C negative is awful as a leaving group, but O negative, can leave as a leaving group. When you're just looking at the thing from the beginning. Does anybody else have any questions about this, especially that cyclization step?
Yeah, I do.
Let me actually, before you ask, I'm going to go ahead and number this to make it a little bit clearer. Okay.
Thank you. You covered this in the video, and I actually had trouble trying. Oh, sorry, that's my phone. I apologize. Trying to figure out if the two rings are attached or separate.
Okay,
and I was wondering if you were going to cover that.
I definitely will, Jasmine, but not right now.
All right.
That is definitely something, because I'm going to cover question 2 in a great deal of depth.
Okay.
But I have to lay the groundwork for it first, Jasmine, by showing the mechanism just for the cyclization itself.
Okay, gotcha. Thank you.
All right, but I will go through that. Any other questions about the cyclization step here? All right, so just with regard to the cyclization, let's do a poll here. Okay, so just the cyclization step. I want to see who understands it, who doesn't. Okay. I'll give you 5 more seconds. 5, 4, 3, 2, 1. Okay. So the one person who halfway understands, is there a question you could ask that would help you with the cyclization step? I'm just talking about this step here, just this one step. All right. It's completely anonymous. I don't have any clue about who answers what here. So the next step, according to the pattern, we're looking at the acidic reaction here, is a proton transfer. And the proton gets transferred to the leaving group, which is going to be the group originally attached, the Y group, if you will. And in this case, it really doesn't matter which you choose because they are the same, I suppose. But we get a proton transfer in the next step. And then in the last step, the leaving group leaves and the C double bond O reforms, and we end up getting our products. Does anybody have any questions about the mechanism here? It's a little harder to see, but it does follow the acidic pattern that I have over here on the right-hand side. The only difference here is that the XH group that's attacking is actually attached to the same molecule as the C+, which is why we're getting a cyclic product. Does anybody have any questions? Okay. All right. So I think here might actually be a good place to stop, because I want to go through exactly what Jasmine was talking about in how to figure out whether the rings are going to be fused or whether they're going to be separate when we're talking about a dual ring closure type situation. And that's not something I can cover in 5 minutes. So I'm going to stop it here, and we'll continue with the fun of this on Thursday. In the meantime, feel free to practice those other problems, especially with regard to figuring out what the products are, just by using the patterns, and see where you go from there. All right, so we'll leave it there for today. And anybody who wants to hang around and talk to me, you're more than welcome to. Okay, see you all on Thursday.
Thank you.
Thank you.
Have a good one. See you
You
Thursday.
too.
Thank you.
Dr. Musgrave,
Yes, Courtney?
on Thursday, are you gonna be mostly going over the two mechanism questions and the synthesis?
No, maybe not the synthesis. The synthesis I'm probably going to leave till the end.
Okay.
But I will focus on the mechanism questions most likely on Thursday.
Okay, perfect. And then Tuesday will be a review day, and then the test is Thursday, correct?
Let's have a look. Let me look at the schedule here. Let's see, syllabus. So we've got what's today? Today's the 23rd. Yeah, so I'll be doing that, and then yeah. Yeah, that sounds right. So the synthesis problem, I'm not really going to spend a great deal of time on, because it's very similar, at least in means, what we were doing in test 2.
Right. Is there going to be a pattern in it, like last time, the PCC pattern?
No, not really.
Okay.
But you will. But what I will say is that you'll be able to use reactions from question 1.
Which will be the same for roadmap too, right? You can
The
use
roadmap,
same.
no, I wouldn't say that's true.
Oh, really? Oh,
Yeah.
dang.
Oh,
This is
dang.
scary. It's
I
scary.
know.
Okay. Well, I'll
All
just have
right.
to start preparing. I feel like
Yeah.
spring break messed with my
Yeah.
motivation and stuff.
Well,
Yeah.
also the fact that also the fact that I didn't do any Zoom lectures last week kind of annoys people a little bit too, I think. But
A little bit. I mean, your mini lectures kind of do the same thing as the lecture. So I think I
Right.
just lost my flow with school. So
yeah.
I'll
All
just
right.
have to keep studying. But if I think of anything, I'll email you.
All right. No worries. Thank you.
Thank you.
Okay. Bye-bye.